In this section, we're going to look at logarithmic functions. Let's say from our previous examples, like in section 4.1, when there were 3 people initially infected with the coronavirus, and then the number was doubling. Let's say we wanted to know when, based on what was going on, there would be 500 people infected. If we want to find out the answer to that algebraically, we would essentially take this model that we developed in that section and equal it to 500 and then look for time to figure out at what time that would happen. And in order to do that, we would need logarithms to find the answer. And the main thing we want to remember and keep in mind is that logarithms spit out exponents. That's all they do. So if you've never understood logarithms before or found them confusing, just remember that, have an open mind, and think, well, all they do is they just spit out exponents. The expression log base AB, that's how you read it. You say log base A of B, and then whatever that expression is, that expression will spit out an exponent. Here's what I mean. If I'm looking at log base 2 of 8, that basically says 2 to what power will be 8. So you're at 2, you're trying to get to 8, and you're trying to see what exponent is required to make 2 get to 8. So the answer would have to be 3. Since you're thinking, oh, 2 cubed is equal to 8, my answer is 3 because the exponent is 3. Or if I'm looking at log base 3 of 9, I'm basically asking, hey, 3 to what power gets me to 9? And so the answer would have to be 2, because you know that 3 squared is equal to 9. So in each case, the logarithm is just spitting out the exponent. Next example, log base 4 of 64 says 4 to what power will be 64? So I'm at 4 and I'm trying to get to 64. The power required must be 3. Since you're thinking 4 to the third gives me 64. So again, just keep in mind it's spitting out exponents. Next one says log base 7 of 1. Well, that says 7 to what power is going to get me to 1? Well, we know if we raise 7 to the 0th power, we're going to get 1. Since 7 to the 0 is 1, that logarithm spit out the exponent of 0. Next one says log base 10 of 100 is pretty much equivalent to, try to fill it out with me, 10 to what power will be 100? So the answer would have to be a 2, since 10 squared is equal to 100. That's what you're basically thinking in your head, and the exponent popped out is 2. Try to do the next 3 on your own. Pause the video and then I'll come back and go over it. So this next one says 10 to what power will be 1 over 10? And so to make that a reciprocal, the exponent would have to be a -1, since 10 to the -1 is equal to 1/10. Log base 2 of -8 says 2 to what power will be -8. Well, 2 to what power will be -8 is going to be an issue, because no matter what power I use, I'm always going to get a positive exponent. For example, 2 to the, I don't know, -1 is a half. 2 to the 0 would be 1. 2 to the anything bigger than 1 would end up giving me bigger and bigger numbers. So there is no exponent that will pop out a -8 for me, because whenever I raise something to an exponent, it's going to give me a positive number. If my base is 2 or 5 or 10 or 11, the minute I raise it to an exponent, it's going to spit out a positive value. So the answer we'll say is undefined. No exponent exists. Similarly, this one says log base 10 of 0. So 10 to what power will be 0? Well, it's the same idea. 10 to the what gives me 0. Notice even if I raise it to the 0th power, I get a 1. If I raise it to the negative power, I get a 1/10. If I raise it to positive powers, they keep getting bigger and bigger. So there's no exponent that will allow me to pop out a 0. The minute I take 10 and I raise it to an exponent, it's always going to give me a positive number, either something big or something small if the exponent is negative. So I hope you're feeling a little bit more comfortable with logarithms. Again, you look at the base, you look at what's called the argument, the number in front of the log. It's called an argument. So log base a of b basically tells you a is the base, b is the argument, and I'm trying to get to b, give me the exponent. So remember, they just spit out exponents. Some things to note: base 10 is a logarithm that's a common logarithm. So we're going to end up not writing the base at all. I put it in the previous examples, but the minute you see log of 100, you're going to automatically assume there must have been a 10 there because that's a common logarithm. It's technically left out. In general, based on what the examples we just saw, log base a of x equals y is equivalent to saying take a, raise it to that exponent that got spit out, and you're going to get the argument back. In other words, if I go back, let's say, to the very first example, the 2 was the exponent, or the base, I'm sorry. The 2 was the base. The 3 was the exponent, so it went in the exponent spot. And 8, the argument, was on the other side. So if you just do what I call the circle, everything will easily transform from log form to exponential form. So in this problem, I take the base, I go in a circle, next thing I pick is the y, and then I come back to the argument. And that gives me a as my first item. Then when I'm going in a circle, I pick up my y, which is the exponent, and then I come back and land at the argument, and that's what I equal it to. So let's go practice this idea. The equivalency of a log form versus an exponential form. So this we'll say is the log form. Let's put a side note. And this guy is the exponential form. Log form has the word log involved. Exponential form just has exponents involved. So that's what we're going to practice, switching back and forth between the two forms. First example says, put in exponential form. So I'm just going to do the circle and say 3 raised to the second gives me 9. So log base 3 of 9 equal to 2 is essentially saying, hey, 3 squared is equal to 9. These are all the ones we practiced upstairs. 7 raised to the 0 gives me 1. That's all that's saying. Next one saying 4 raised to the 3 gives me 64. Now go ahead and pause the video and try to do parts D and E on your own. Alright, so for part D, we have a missing base, which means it must automatically be 10. So I've got 10 to the second gives me 100. And all of these, notice the math makes sense. 10 squared is equal to 100. And the last one says a raised to the y gives me x. So a raised to the y is just x, which is what we had discussed above when we said in general this is how exponential and logarithmic form work. Now in example 2, we're going to go the other way and put it back in logarithmic form. So naturally, if I'm putting it in logarithmic form, the first thing on my paper should be log. And you can tell that the base of part A is 5. The exponent that got spit out was a 2. Remember, log spit out exponents. So the only thing left is the 25, which must have been the argument. Make sure you write log 25 equals and 2 on the same line, and only the 5 should be lower. Please make sure your notation is correct. Like I said, the only thing lower on your paper should be the base 5. Everything else on the same line. And the next one, I'm gonna, for all of these, since I'm putting them in log form, let me just fill that in. and put the log in, because if I'm putting it in log form, I'm going to need the word log. So the base in this problem in part B is 7, and the exponent that got spit out must be 2. So I'll put that on the other side of the equal sign. So the argument must have been 49. And if I do the circle on that, 7 to the second does give me 49. In part C, the base is 10. I'll leave it there for now. And the exponent that got spit out, that'll be on the other side of the equal sign, is -1. And the only thing remaining is the 1/10. And 10 to the -1 does definitely give me 1/10. And since we have a common log, it's also okay to write it as just log of 1/10 is equal to -1 and leave the base 10 out altogether. Pause the video and try parts D and E on your own. Alright, so for part D, the base is clearly 10. The exponent that must have been spit out is this guy, so I'll go put that on the other side of the equal sign. And the argument must be 700, that's the only number I haven't used. And again, if you do the circle on that, you will get the original back. Part E, the base in that problem, oh, by the way, if you want to write this as log of 700 is 2.845, that's fine too, leaving the base out since it's a 10. Part E says log base, the base in part E is A, the exponent that must have been spit out is y, so I'll put that on the other side of the equal sign. And the only thing remaining is the x, so that must have been the argument. And again, for all of these, once you have it, you can always go check, and it will give you the original that you started with. So keep in mind again, logarithms just spit out exponents. Now let's go practice evaluating some. Example 3 says log base 5 of 125. So you're thinking, all right, this guy is going to spit out an exponent. What exponent will it spit out? Well, I'm at 5 and I'm trying to get to 125. So the exponent I need must be 3, since 5 to the third gives me 125. That's what you're thinking in your head. Part B and C, pause the video, try them on your own. Okay, so for part B, I'm at 9, I want to get to 1. The exponent required must have been 0, since 9 to the 0 is 1. That's what's going on in your head. Part C, I'm at 3, I'm trying to get to 81. The exponent required to get 3 to 81 must be 4, since 3 to the 4th is equal to 81. So all we did was just spit out exponents. Your calculator has the common base 10 with just the word log, and also the natural base e with the word ln involved. So whenever we see log base 10 of x, like I said before, you just want to think of that as log x with no 10 involved. And whenever we have log base e of x, we never really write it like that. We just write it as ln of x. So the minute you see ln of x, you're thinking in your head, oh, that's a logarithm with just base e. So in the next video, we're going to go ahead and use the calculator to either approximate or find exactly what the values are in example 4.